So, what are we looking at? We are looking at the present value of the cash flows. Looks very confusing, don't worry, we will go to the whiteboard. So, we are looking at annuity, we are looking at perpetuity. Perpetuity, let's sort of underline this perpetuity. Perpetuity means what? Perpetuity means what? Let us see. I am going to get a particular cash flow next year, or as of today, that is going to be discounted at some percentage to know what is the present value as of. That is what we did in a single period case. Now, I am going to get a particular cash flow in the next year also, and I have to discount it for 2 years, because why not this year and end of next year? Today, for let us say Jan 1st. I am going to get some more cash flows in the third year, I am going to discount it for 3 years. I am going to get some more cash flows in the fourth year, I am going to discount it for 4 years out there, and so on and so on. I am going to get some cash flows in year n and 1 plus r to the power of n out there, that n nobody knows. Sum of all these is basically what we call it as the present value of that investment out there. Because imagine I give you a perpetual cash flow of 10,000 rupees every month. I keep on discounting the 10,000 rupees at a percentage, say 5% or whatever. Then I sum up the whole thing, that is what is the present value as of now. So, if you take this, there is nothing but the present value of this will be cash flow, which is going to be constant, which is not growing, divided by 1 plus r will basically give me that, what do you call it as, perpetuity cash flow, or perpetuity cash flow, and that is cash flow divided by my discounting rate, divided by my discounting rate out there. That is what is going to give me, what do you call it as, cash flows out there, present value of the cash flows. In the case of a perpetuity, I just discount the cash flow at my expected rate, that will give me my, what do you call it as, my discount rate, my present value. Take an example, in this particular case you see this. British console that promises to pay 15 pounds every year forever. Your discounting rate is 10%. So, what is it? 15 pounds every year discounted at 10%, 15 divided by 10% out there, that is all. So, present value is 150 pounds. If I pay 150 pounds, I can get 15 pounds every year for time immemorial, so that my expected return of 10% is met out there. That is what we say perpetuity. Beyond this, we go for growing perpetuity. Imagine this perpetuity also keeps growing. Imagine this perpetuity also keeps growing in that particular case. Let us say in this particular example what I took out there, let us say in this particular example what I took out here, I say growing perpetuity. Then what happens? My first year, the present value will be my cash flow out there. I will just use the word alphabet C divided by 1 plus r. Next year, what is going to be the cash flow? The cash flow will grow at some rate, 1 plus g, 1 plus r square. Third year, what happens? This cash flow will grow at g square, because this is also growing. So, 1 plus r cube plus cash flow growing at 1 plus g to the power of, cube out there, divided 1 plus r to the power of 4, so on and so forth. So, cash flow into 1 plus g to the power of n divided by 1 plus r to the power of n, rn minus 1 here. I will just rewrite this. Is equal to cash flow into 1 plus g to the power of n minus 1 divided by 1 plus r to the power of n. So, what happens? This I will write it as present value will be cash flow by R minus G out there. That is all. This will give me what is the present value of the growing perpetuity in this particular case, as we can see from this particular example out. I have taken an example also. The expected dividend next year is 1.3 and the dividend is expected to grow at 5% forever. So, what is it? 1.3 divided by my discounting rate is 10%, 0.1 minus 0.05, that is present value of that dividend what you are going to get for time immemorial, which is going to grow at the rate of 5% is $26. Present value of the dividend what you are going to get for time immemorial, which is also going to grow at the rate of about 10%, sorry 5%, given your expected rate of 10% is nothing but 26. That is what we call it as growing perpetuity. So, do we have some numericals and all this? Yes, I have enough number of numericals listed on all this. I have basically listed a couple of about 16 or 17 numericals out there. All that I have picked up from the prescribed textbook. Please note, I have not picked it up from any other source. I have picked it up from the prescribed textbook. You can either refer the prescribed textbook and take care of solving most of the exercise problems, or you can also look at these. I will solve out of 17, I will solve about 3 or 4 as we go along in the next couple of minutes out. So, after growing perpetuity, what we see is annuity. In annuity, I am not going to write down. Here, what happened? The time period, the same cash flow is occurring. Unlike a perpetuity, unlike a perpetuity out there, in this particular case of annuity, this part does not basically what do you call it as this part, there is what is called as a definitive closure. This N does not exist, it becomes rather T, that is what happens. So, what happens? There is a fixed standardized period for this. This is a fixed standardized period for this, that is why it becomes T out there. Known. The number of years of cash flow is known T, whatever it is. So, how do I find that? My cash flow that is going to occur constantly, there is no growing annuity, constant, divided by my discount rate R into 1 minus 1 by 1 plus R to the power of T. T means the time period out there. What annuity? I will take up an example. If you can afford about $400 monthly loan payment, EMI typically, on a car purchase, how much of the loan can you afford if interest rate is 7% and the tenure is 36 months? You can pay 400 every month maximum, but interest rate at 7%, timeline is also given 36 months, 3 years. How much can you borrow? That is all what we are asking. So, what happens? The tenure is 36 months, 3 is fixed. In this particular case, the T part of it is basically fixed out there. T part of it is basically fixed out there. In this particular case, the T is fixed out there. In this particular case, let us say annuity. My T is 36 months. My R is 7%. My R is 7% out there. My cash flow is $400. So, what happens? It will be 400 divided by 7%. It is 400 divided by 7% into 1 minus 1 by 1 plus 7% to the power of what do you call it as 3 is what I will do. If you want to put it as monthly, yes, of course, yes, 400 divided by 7% per annum, so 12 months into 1 minus 1 by 1 plus 7% by 12 into 36 months out there. So that is basically what I have basically done in this particular case. I'm just searching out there. So what happens in this particular case, if you do that, you will get about 12,954.59. So if you borrow 12,954.959, you can repay the entire loan at the rate of 400 for 36 months at an interest rate of 7%. If the interest rate is 7% and if the tenure is 36 months and if you can pay only 400, maximum you can borrow is 12,954. If you borrow more than 12,954.759, you will not be able to complete the loan in 36 months at a 7% interest, given that you can pay only about $400. So what we do? Annuity. It's an annuity, fixed time period. From here I go to the next stage, what is called as growing annuity. The amount in this particular case, the amount of payment what you had to pay is fixed. If that itself is growing for a fixed period of time, then how do we look at what is the present value of it? What is look at present value? We have taken a formula. Sorry, we have taken a problem. A defined retirement benefit plan offers about $20,000 per year for 40 years. An increase in annual payment by 3%. The present value is 10%. Present value or the discounting rate is 10%. So what happens? This $20,000 is discounted at 10%, but it is also going to grow at rate of 3%. So 20,000 divided by 0.1 minus 0.03. So net result, you have to discount it only by 7%. That's what we see. And this 20,000 is going to grow. That is where you see the 1 minus 1.03 divided by 1.10. So as you could see, 1 plus G growth rate divided by 1 plus R. That is what we are looking at. To the power of the tenure 40. So what happens? If you want to get 20,000 rupees growing at the rate of 3% every year for about 40 years, you will invest about 2,65,121.57. You will invest about 2,65,121.57 out there. Okay, this is what we call it, growing perpetuity. From here, I move to a little more. So, what did we learn? We learned about discounting. We learned about future value. We learned about present value, single period case, 1 year. Future value, multi-period case. We learned about annuity. We learned about growing annuity. We learned about perpetuity. We learned about growing perpetuity. And we also learned about NPV, net present value. Net present value is nothing but, I have a cash outflow today. I am going to get cash inflows in the next year or the year after, or whatever it is. What is the value of that cash inflow that I am going to have in whatever in future as of today? What is the value of the cash inflow that I am going to have? The value of that cash inflow as of today. The difference between the two is NPV. If the NPV is positive, worth for you to invest. NPV is negative, not worth for, because you are not getting your money. You are getting lower than the money what you are investing as of today. That. In the next class, we will move to the next aspect, that is, we look at a little bit using the discounting concept. We will get into what is called as valuation of bonds and stocks out there, and subsequently we will use a little bit of the discounting again of the present value and the internal rate of return, and with that we will close the first part out. Next class, we are going to spend some time on valuation of bonds and equities. Now, I have got a lot of numericals out there. You can basically work on all these numericals. You can work on all these numericals out there. Let us say, let us start with this. Let me start with the second question out here. Stu can purchase a house today for about 1,10,000. Including the cost of minor repairs. He is expected to resell it in 1 year at 1,29,000 after cleaning up the property. At a discount rate of 5.5%, what is the present value, net present value of this purchase opportunity? Let us sort of look at this. net present value. Let us look at problem number 2 in this particular case. Problem number 2 in this particular case out. What does he say? It says that he purchase price 1,10,000. Sale price 1,29,000. Discount rate 5.5%. So, what is the question of? What is the net present value of the purchase opportunity, NPV? Let us look at the present value of the sale price. What is the present value of the sale price? 1,29,000 divided by 5.5 divided by, what do you call it, as 1 plus R. I'm just doing it 1 plus R, 1 plus 5.5% out there. That's all what I'm going to do. I think you selected D7. No, sorry. I just I made a mistake. Yeah. So, what happens if I sort of look at it in this particular case out here? So, what happens in this particular case out there? I'm just doing the formatting. So, my sale price is 1,29,000. The present value of the sale price is 1,22,274. So, the NPV, the net present value, is nothing but this is the sale price. This is this is the, so what is the NPV in this case? NPV in this case is nothing but this is the present value of the sale price. This is the money I am going to get. What is the money that I am going to invest as of today? This is the present value. This is the value of the money that I am going to get as of today. What is the value of the money that I have invested? This is the value of the money. So, what happens in this particular case out here? This is what is, it's unfortunately formatted as a percentage. So, I'll just got it. So, what happens? Your present value is about 12, the net present value is $12,274, what you got. See, you stand to gain positive net value. Let us take up 1 or 2 more examples of that. Let us take a problem number 5 in this particular case. Let us take up problem number 5 in this case. Sean has 2,500 invested at a guaranteed rate of 4.35% compounded annually. What will the investment be worth in 5 years? Future value. What we are calculating is future value out here. What we are looking at is future value in this case. That means invested 2,500, that is investment is 2,500. Rate is 4.35%. Compounded annually. Time period is 5 years. Time period in years. Is 5 years. What does it say? What will the investment be worth after 5 years? Please note, this is getting compounded annually. 2,500 is getting compounded annually. 2,500 into 1 plus 1.435, 1.0435 to the power of 5 out there. This is what basically is what we are looking at in this particular case. it will be worth about 3093.15, 3093.116. Let us take up the seventh one. A project is expected to produce cash flows of 48,000, 39,000, 15,000 over the next 3 years respectively. After 3 years, the project will be worthless. What is the net present value of the project if the applicable discount rate is 15.25% and the initial cost is 78,500? Let us do the seventh problem out here. Cash cost of project minus 78,500, because cash outflow, that is where minus. Year 1, what is the cash inflow? 48,000. Year 2, what is the cash inflow? 39,000. Year 3, what is the cash inflow? Cash inflow is 15,000. What is the discount rate in all these things? What is the discount rate in those things? 15.25%. So, what is the present value of the cash flows? PV of the cash flows. Cost is as of today, so it will remain the same, 78,500. PV of the first year cash flow. So, what are we looking at? We are discounting this 48,000 for 1 full year out there. That's all. We are discounting this cash flow for 1 full year there. That's it. I'm just going to keep reducing the what do you call it as the decimals out there. Second year's cash flow. I would say it is the same 39,000 I'm going to get. I'm going to get it for how many years? This much of time. To the power of what? To the power of 2. Why to the power of 2? Because I am going to get it only for 2. I am going to get it at the end of 2 years out there. And this is what is the value of what I am going to get at the end of second year as of today. Present value, PV. Third year's cash flow. Third year cash flow is 15,000 I am going to get divided by, what do you call it as, 1 plus this 15.25% to the power of 3, and this because I am going to get at the end of 3 years. Yes, this is what it is. So, the 15,000 what I am going to get is worth only about 9,798 as of today. So, what is the NPV of it? What is the NPV of it? NPV of it is about 2,309 net present value. It has a positive net present value out there. It has a positive net present value. Because it has a positive net present value, I will go ahead and invest in this project out there. Let us look at the ninth problem. And I think with that we'll stop. I leave this problem sheet. You guys can work on your own. I'm just going to do one more. You are offered a job with an annual salary. First year 48,000. Second year 51,000. Third year 55,000. Next 3 years. The offer also includes a starting bonus, that is of 2,500. That is bonus as of today. That is PV. The bonus as of today is about 2,500. Your discount rate. What is the offer worth to you today at a discount rate of 6.5%? Discount rate is 6.5%. So, what is that? What is the offer worth as of today? Let us look at, what we have to do. We have to find present value of future cash flows. Bonus remains the same at 2500 because it is the present value, because you are getting paid today. Next, first year salary, what is the present value of that? That is about 48,000 divided, that is at this money divided by 1 plus 6.5% out there, and that is all what we are getting. It is worth about 45,000. Second year salary, it is about 51,000 divided by 1 plus, divided by 1 plus 6.5% to the power of 2, because discounted for 2 years out there, and that is what it is. Third year salary, I am going to get 55,000 divided by 1 plus 6.5% to the power of 3 out there. So, what is it? This is the present value of the future cash flows. Present value of my salary is what I am going to get. So, what is it worth? It is worth the sum total of all this. It is worth at about 1,38,066.75. It is worth about 1,38,066.75. That is the money that it is worth. Right? So, similarly, you can do a lot of numericals. Many of these present values can be done using an Excel function itself. We will talk about this using the Excel function and working out here. We will talk about it in the next class. That is what I can go to more functions. I can say, look at all these things, present value. I can say PV, and then I can do all these things. Future value, FV is future value, PV is present value. I can also do NPV, net present value. I can do all these things here. I have not done anything using Excel function as of today. We will do it as we go along. Okay, thank you.